Okay, so I want to go through any of the probability. I want to go through any of that probability homework with you that you might still be having problems with. So does anybody want to start? I'm just going to let you guys start asking questions. We can try to go in order if you guys want. Like we can start with section 3.1. Does anybody have any questions from 3.1?
One moment.
Okay, so everybody's good with 3.1. Does anybody have questions on 3.2?
I would say that most of my questions come from 3.2.
Okay, awesome. Let's just go in order. So does anybody, let's just go through, like, does anybody have questions on 1, 2, or 3? And from 3.2?
Not off the top of my head.
I have a question about 3.1.
Oh, okay, let me go back then. Hold on, let me go back. I don't want to miss anything here. Okay, questions. Okay, which question are you looking at in 3.1?
So mine is question 8. I don't know.
Okay, question 8. Okay, I'm looking at question 8. Now, be aware that, like, when I look at this, like, they scramble the numbers so that it's a little bit different, but the process will be the same, okay?
Okay.
So is it all of the parks in that
Yeah.
number 8, or is it just
The
like
whole thing.
okay? Let's see. Okay, so number 8, and I posted, I think I remember this problem because I remember I inserted that picture in there. So you guys see the picture in case you're not familiar with the deck of cards, okay? So you have all the cards there. And it says, part A says, what is the chance of getting a 7 of spades? So just a refresher, there are 4 suits, right? There's clubs, spades, hearts, and diamonds. And then there's ace, 2, 3, all the way up to 10. And then there's jack, queen, king. So how many total cards are there? So this is number 8 in section. Can you guys see my iPad okay? Do you see me writing?
Yes, I can.
Okay, good. Okay, so part A says we want to see the probability of getting a 7 of spades. Okay, so how many total cards are there in a deck of cards?
52.
Yeah, 52. And if I just at random pick out one card, how many 7 of spades are in there so I can figure out the probability?
It is a 1. I'm not familiar with cards that much, but isn't it 1?
Yeah, there's just one 7 of spades in that entire deck of cards. So it'd be a 1 in 52 chance, and then you would just have to put it in a decimal, rounded to, in my version, it says rounded to 4 places.
Okay.
So for me, that would be 0.0192 if we rounded it to 4 places. Is everybody okay with part A? Or sorry, yeah, part A.
Yeah.
Okay, part B says, what's the probability of getting a club or a diamond? Okay, so remember, when you're doing an or statement, you have to keep in the back of your head that you want to add those probabilities together, or means to add. So I want to add those probabilities together, the probability of having a club plus the probability of having a diamond. But if there's any overlap, I don't want to count something in there more than once. So if there's any overlap, I want to subtract that off. So that's why we subtract the probability of having a club and a diamond. Okay, so since there are 13 clubs in the deck, that would be a 13 out of 52 chance of getting a club. And so you don't forget you have that picture there. You can help yourself by like counting the cards if you need to. And then what's the probability of getting a diamond?
We wanted to be the same, 13 out of 52.
Yeah. Now, are these events mutually exclusive? Can I have, if I pick a card, can it be a club and a diamond at the same time?
No,
No. So in this case, it would be considered mutually exclusive. So the probability of this would be 0. So you would just take 13 out of 52 plus 13 out of 52. And then you would add that together. So you would get 26 out of 52. And then when you round it to a decimal place, you would get 0.5. Okay, part C said, find the probability of a number smaller than 3. And it says in parentheses, for me, it says we're going to count the ace as a 1. So if I get a probability, let's see, probability of something smaller than 3. So that means getting an ace or a 2, strictly smaller than 3. So we're not going to count the 3s, just ace or a 2. If it says a 3 or smaller than the 3, then we would count it. Okay, so this is an or statement. Is this going to be mutually exclusive? If I pick a card, can it be an ace and a 2 at the same time?
no.
No, so I don't have to worry about subtracting overlap here. So I'm just going to find the probability of getting an ace and then add it to the probability of getting a 2. So how many aces are there in a deck?
4, correct?
Yep, 4. So 4 out of 52. And then there's 4 2s as well. So 4 out of 52. So I would add that and get 8 out of 52. And then you can put that in decimal format and round it to whatever they tell you to put in. Is there any questions, anything that you need to go back over from A, B, or C?
I understand it myself.
Okay, who asked that question? Was that you, Kalia?
Yeah,
Is this better now?
honestly, no. Because I don't see what you're saying, and I feel like maybe if it's like one of my problems, I would kind of understand it more because I'm not understanding how
Do you have
like
the
your
picture-
numbers are coming.
Do you have the picture of the deck of cards in front of you?
Yeah,
Okay,
I
what
do.
if what is your question for part A?
it says an 8 of clubs.
Okay, so look at the picture.
Okay.
And how many 8 of clubs do you see in there?
So I don't play cards, and am I just looking at the ones that have the number 8 on them?
Yep, and then clubs is the one, can you see my screen, Phil? So this is the one that looks like this. Am I drawing that right? The one that looks like this is a club. The one that looks like this is a spade. And then, of course, these are diamonds. And then what was the other one? Oh, hearts. I feel like hearts and diamonds you would be okay with. The clubs is the one that looks like kind of like a clover.
This is what mine looks like my stuff.
The picture is gonna be the same no matter what. A
Okay,
deck of clubs
so-
is the same no matter what. So
Okay.
how many 8s has a club on it?
Oh, can I see your little picture thing again so I can see what you just drew?
Oh, yeah, this is clubs. It looks kind of like a clover, but with 3 instead
Okay.
of 4.
Um,
And then this one looks like this is a spade.
okay, I think I only have one.
Correct. There's 1 8 of clubs out of how many total do you have?
I think 52.
Correct. So yours is going to be 1 out of 52, and then you just put it in decimal format.
Okay. So the B part is asking for a spade or heart.
Okay, how many spades do you have?
I don't know what the spade is.
That's on my picture here.
Okay.
It looks
Um,
like that. Or maybe it doesn't have the little thing at the bottom. I think it just looks like this. It's the other black suit. There's only 2 black suits, 1 club and 1 spades.
I don't know. It looks like 9 for me.
For clubs, all the
Yeah.
clubs are in 1 row. I'm sorry, did you say spade or club?
Spade. It says a spade or heart.
Okay, let's do spades first. All the suits are in 1 row. So you can see all the clubs are on the top row. Then all the spades are on the second row. When you're looking at your picture, then all the hearts on the 3rd row, and then all the diamonds are on the 4th row. Do you see that?
Yeah.
Okay, so
Okay. 13.
correct. Okay, so there's 13 clubs. Now, how many diamonds do you have?
I think 13.
Okay, so that gives you a total of how many? 13 and 13.
26.
Yeah, 26 out of a total of,
52.
correct. So do 26 over 52.
0.5.
Correct.
Okay. All right. I think I get it now.
Okay. I think
Okay.
I think some of the issue is that you didn't know, you weren't familiar with the deck of cards.
Yeah.
Part of it.
Yeah, it was.
Okay,
Thank you.
you're very welcome. Does anybody else need help with anything from section 3.1?
For myself,
yeah.
I'm good for it.
Okay, so I think I heard one person say you're good. Did someone else say that they had something?
Yeah, I was wondering about question 13.
Okay, let me pull this up. Number 13. Can you guys still see my iPad okay?
Yeah,
Okay,
Yeah.
if something happens and it loses connection, just let me know, okay? Okay, so we have a contingency table here. We have male, female, and then we have binge drinkers, and then non-binge drinkers. This is kind of funny. All right, let's see. And then we have the total. Let me go across here and write all of this down so you can see what's going on.
I was gonna say that's my number 12 question. That's not my number 13 question.
Am I on the right one? Let's see. You said number 13, right?
Yeah. Mine's about giving a test to a group of students.
Oh, okay. Maybe something must have happened with the order.
So on my screen, my question 12, it has a red notice. This question was withdrawn by the instructor. You do not need to complete this question.
That's not okay. So I must have messed up. you guys are in different sections. I must have messed up the order from section to section because I was trying to keep the order the same for this very reason, but I must have messed it up. Okay, so yours is the one with the test, you said. The male versus the female. And then whether you got an A, B, or C, was that yours that you're asking about?
Yes.
Okay,
And then my biggest one I was having problems with is the wording. So like in this one, it says find the probability that the student received a C in the class given they are female. And then the next one says, and the student is a female given they received a C in the class.
okay, it sounds like it's asking for the same thing. And this is
Correct.
one of the thing that makes math a little bit tricky. The devil is in the details. You really have to pay attention to details. So let me see, that was the part. What part was that for you? So I can make sure I'm looking at the right one.
Part D and E.
When they are female. Okay, so part D was, so this is the notation. Okay, so I'm gonna, no, okay, so this. Okay, so the F, I'm gonna write, that stands for female, okay? And then the A is that they got an A in the class. So using my chart here, what I want you to do is remember that this second part that I just highlighted in yellow, that is the assumption. So what this is saying is, if we look at part D, it says, we're gonna assume that when we find the probability, we're looking at only females. We're assuming that the person we're looking at is a female. So that means if I look at just the females, I'm looking at this row right here. You see what I'm looking at?
Correct.
Okay, so now looking at just the row that I highlighted, because I'm making the assumption that the person is female, so I can ignore all the males.
Right.
Okay, so what is the probability looking at just that row that the person is going to be a female? Or sorry, the
Receiving.
person's going to get an A, I'm sorry. What's the probability?
11,
Right, 11 out of,
28.
right, there you go. That's it. Now we're doing it the other way. So let me highlight it the other way. So now in the second part, in part E, we're looking at just, we're assuming that the person got an A. So now we're
Right.
looking at this row or this column.
Okay. Okay. That makes sense. Okay.
Okay,
should be
so
good.
now I'm looking at what is the probability that I pick a female?
Be 11 over 19.
Right.
Okay. I'm
Does
good.
that-
For some reason, that just tricked me up. So I'll be,
Yep.
should be good.
So
with
what I
that.
would say, if you have a conditional, always look at that part where they say it's given. And it basically narrows it down to that subcategory, and you're only taking it out of that group.
Okay. Okay. That's good. Thank you.
Okay, awesome. Now, I do want to point out, because a lot of people get confused with this, this is a really good time to bring it up. If I add on, I'm just going to make a part, I don't know, I'll make a part after this. If I asked you the probability of getting an A and getting a female, a lot of people get these three things mixed up. Notice that this isn't conditional. I'm not taking it out of a specific group. If I'm not making any assumptions, I'm taking it out of the full group, the whole sample. So if I'm looking at the probability of the person being a female and getting an A, that means I'm getting 11 out of 68. I'm looking at the whole group. Do you guys see the difference?
Yes.
Okay, excellent. Okay, any other questions from 3.1? Okay, let's go on to section 3.2 then. Let's see, I think I have that printed out here. Okay, so. Okay, what questions do you guys have from section 3.2?
I had a question about, it was question 2, but it was like the same type of questions for number 3 and 4 as well. And it was like U and V are mutually exclusive events. And it gives their values, and it said like find P, U, and V, P, U, and given that V has happened and stuff.
Okay, so looking at number 2 in section 3.2, my numbers are, this is number 2. My values are the probability of U is 0.35. The probability of V is 0.51, and we're told that these are mutually exclusive. Can anybody remind me what mutually exclusive means?
It's equal to
Like-
0.
Well, the probability of what is equal to 0?
Of, in this case, U and V.
Right, U and V, the probability of U and V happening together is 0. So if you look at it like a Venn diagram, assume that this is U and this is V, the probability of them happening together at the same time is 0 because there's no overlap. It's impossible for them to happen at the same time. And I think the example that I was giving that seemed to help everybody understand is if I ask you, what's the probability of my car being, say, a Honda and a Ford at the same time? What's the probability of my car being a Honda and a Ford? That's impossible, right? It's not going to happen. So those two things don't overlap. They can't happen at the same time. So for part A, when it says find the probability of U and V, we would say 0, right? Is everybody okay with that?
I get it. But I wasn't the one who asked the question.
Okay, what about the probability of U given V? Okay, so this means this notation means V has happened. We're assuming that V has happened. That's our assumption. So what's the probability that U has happened if we know V has happened?
0.
Right, because we said they can't happen at the same time. So that's a way you can look at it in terms of like common sense, okay? But if you look at it in terms of, if you like a formula person, remember the formula that we have for U and V would look like this. Times the probability. Whoops, I wrote it backwards. Right, so this is my formula if I'm using my formulas. And if I say that I know that this is 0, and I know that the probability is given to me in the problem is 0.51, and I have this is what I'm looking for, so I'll call it X. So I have 0.51 times X is going to be 0. What does X have to be? What times 0.51 would give me 0?
0.
Right, so whether you look at it in terms of just thinking about it in terms of like common sense or logic versus using formulas, either way, you'll get 0.
Yeah, that makes more sense.
Okay, now part C says find the probability of U or V. Now, if they're mutually exclusive, we know there's no overlap. So all we have to do is add the probability of U and add the probability of V. If there was overlap, then we would have to subtract it off. But I know because this is mutually exclusive, I'd just be subtracting 0. So if I find the probability of U, this was given to me in the problem as 0.35. And then probability of V was 0.51. So when I add that up, I get 0.86.
Okay, yeah, that actually worked.
Okay,
I
good.
wasn't getting zeros, so
Does it make more sense to you now?
yes.
Okay, now, even though it didn't say in the problem that the probability of U and V is 0, as soon as it says that clue that they're mutually exclusive, you can just automatically write that down. It's a given. The probability of U and V happening at the same time is 0 whenever that happens. Okay. All right, what's the next one you guys want to do?
Questions 5 through 8, part A for me, they all use the same formula and I couldn't figure out what it was.
Okay, let's see.
Also part B on those as well.
Why don't we just go through one example with all parts, okay? That might help.
Okay.
Okay, so on mine, this is the one with the dice, correct?
Yes.
Okay, this. All right, I'm gonna draw something on here. And I actually have this in a picture format somewhere. I'll post it on Canvas for you guys so you can have it. I'm gonna make a table on here. If you roll 2 dice, there's 36 possible outcomes. So this would be if I roll a 1, 2. Sorry for my messy writing. If you can't read something, let me know. Okay, I'm going to quickly write out all the possible outcomes because I think when you see it, it makes a lot more sense. Okay, so what I did here is I made a chart. And so this first one here would mean I rolled a 1 on the first roll and a 1 on the second. This one would mean I roll a 2 on the first and a 1 on the second. So I would just come across here and list out all the possible outcomes. Oh, wait, did I write that backwards? This would be, I think I wrote that backwards. Let's see. So that's 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2. Then this would be 1, 3. So this would be that I roll a 1 and a 3, then a 2 and a 3, etc. It's kind of a pain in the butt to write it out, but I want to make sure you guys see this. And like I said, I'll post up this picture that's much more neater written in a table on Canvas for you. My dyslexia is messing with me right now. So that would be a 3 and a, wait, 3, 5. This would be. Whew, almost there. Okay, so these are all the possible outcomes. It's 36, right? 6 times 6. Okay, now for part A in this, it says, let A be the event that you get a 4 or 5 in the first roll. So this is event A. And then an even number for the second roll. So you literally just have to pick out those possibilities from this picture. So if I get a 4 or a 5 on the first roll, that would be these that I just highlighted in yellow. Now, if I get an even number on the second roll, that narrows it down to these that I just highlighted in green, because I want my second number to be even. Did everybody see where this is coming from?
Okay.
Okay, so there's a total of 6 possibilities that would happen. All the ones that I just highlighted in green, that I have a 4 or a 5 on the first roll, even on the second. So that's 6 out of 36. And then you can put that in decimal format. So I really think looking at the picture really, really helps. At least it does for me. Okay, so part B says, we're going to call B the event that the sum of the 2 dice is at most 5. So let me do that in different colors so that we can maybe not get this mixed up. Okay, so for part B, I'm going to do that the sum is at most 5. So if I roll the dice, this would give me a 2, this would give me a 3, this would give me a 4, this would give me a 5. So those satisfy that, right? I want to see which outcomes will give me, when I add up the dice, the biggest value would be a 5. That the 3 would give me a 6. So that's all I could do. Right? Everything that I highlighted in pink, because anything other than that would give me something bigger than 5 when I added it. Are you guys okay with that?
Yeah.
Okay, so how many, let's see, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did I add that right? 1, 2, 4, 6, 7, 8, 9, 10. Yeah, so that's 10 out of 36. And then whatever that value is as a decimal. Okay, so part A, we highlighted in green. And part B, we highlighted in pink. Okay, so this will help us see in part C and D. Part C says, are A and B mutually exclusive? So look at the pink and look at the green. Do any of them overlap? Can they happen at the same time?
Yes.
Okay, which one happens at the same time? Which outcome?
Are we taking a single number or both numbers?
No, it has to be both numbers. We're talking about rolling 2 die.
Okay. So just anyone that's a 4 or 5 with a 6 or a 2 or another 4.
Yeah, but they're asking if event A and B, right, are mutually exclusive, meaning, remember A was the green that we highlighted, right? Those 6 events, let me re-highlight it, right? These 1, 2, 3, 4, 5, 6. Right? Those were the ones for event A. We had those 6. And then event B, we did in pink. That's all of these in pink. Right? Do you see all the ones that I'm highlighting? Now, do any of the green and the pink overlap? Can A and B happen at the same time?
Okay, no, I see what you
Yeah.
mean now.
Right. They're looking to see if any of these outcomes from part A and part B, if those overlap. Now, there might be times where they do, but in this particular case, it doesn't. They don't overlap. So for mine, I would say they are mutually exclusive because there's no overlap.
Sorry, I have a quick question about part B.
Okay.
So I guess just like the wording, when it says at most 5, does that mean rolling any 2 dice that would add up to 5 or lower?
Right.
Oh, okay, that makes
be-
sense.
2, 3, 4, or 5. Now, if it said less than 5, that would mean it doesn't include 5. So that would mean it would be 2, 3, or 4.
Okay. Because yeah, I thought it was only counting the rolls that like added up just to 5. So that
No,
makes
no.
sense.
If it's at most 5, then it can be less than 5.
Okay. Thank you.
Perfect. Okay, so that was, let me erase to make room for the next one. So that was number 8, and you said that number 8, 9, and 10 were similar, I think you said. Does that help answer the other ones too?
Hmm. Well, I was trying for a second question on mine, question 6. Let A be the event that the first die is odd, and the second is a 4, 5, or 6. But I must be slow. I'm not getting the right answer.
Okay, so if, let me see, you said event A, you said that's the probability that you get an odd on the first roll.
Yes.
And then you said, and then the second roll is a 4, 5, or 6. So odd on the first would mean that you could have a 1, a 3, or a 5, right? Those are the odd numbers on the dice.
Mhm.
And then if you just, let me make more room. And then if you just add in the possibility of getting a 5, 4, 5, or 6 on the second die, this is your possible outcomes. 5, 6. Right, because this gives you all the ones I just highlighted in pink. That gives you odd on the first. So that's that one. And then second would be a 4. There's all the 4s, there's all the 5s, there's all the 6s. So that's 9 out of how many possibilities?
36.
Correct.
I guess what always threw me off was, since there are 36 total possibilities and there are half and half is odd and even, I just assumed that odd would be 18. Since it's
No,
all
you're
the
only
odd
looking
numbers.
at the first. You're only looking at the first die. That's why I think when I post that picture for you with that table with all the outcomes, I think that will really help. Let me actually, can I do that right now? Let me see if I have that available. And then that way, if you're in front of the computer, you can look at it. Oh, I don't have that available to me. If you just Google roll 2 dice, all of like a whole bunch of pictures will come up. If you look at the option for pictures, a whole bunch of pictures will come up with that table and you'll be able to see
Okay.
all the outcomes. That way you can visualize it. I don't have that file handy. Was it just part A on that question or was it the other ones too?
For me, it was just part A. I don't know about other people.
Can we go over part B? Please.
So part B was the sum of the 2 dice is 10, right?
Yeah.
Okay, so what are my options on the dice? I could get a 1, a 2, a 3, a 4, a 5, or a 6. What combinations could I possibly get a 10? If I add them up. What are the different ways that I could add a 10, that I could add two numbers and get 10? Could I roll a 1 and a 9?
Yeah. And then like, are we adding like the 1, 2, 3, 4, 5, 6 or?
We're
Like,
rolling two
well,
dice. So the only ways that when we roll and we look at the dots on the dice, right? We're looking to see, right? I could get a 1, 2, 3, 4, 5, or 6 when I roll the first dice. And when I
Okay,
roll the second dice, I could get a 1, 2, 3, 4, 5, or 6, right?
yeah,
So could I roll a 1 and then a 9 on the other dice?
yeah. To make 10?
Is there 9 on a dice?
No.
Okay, so what are my possibilities again? 1 through 6,
So
right?
like a 4 and a 6?
Yeah, there you go. So I could get a 4 and a 6. I could also roll it the other way and get a 6 and a 4.
Okay.
And there's only one other way to get a 10.
And then 5 and a 5?
Yeah, perfect. Exactly. So there's 3 out of 36 possibilities.
Okay.
Does that make sense
Yeah.
now, what I was saying?
Yeah, it does. Thank you.
Perfect, perfect. You guys need to start playing some games. You can get familiar with cards and dice. Okay, what else from section 3.2 do you guys want to go over?
I need help on 16 and 17.
Okay,
And
6 and which
I'm
one?
not particularly picky. Anything except question 24.
So we said 16 and 17. Are they similar? Let's see.
Yes,
Okay, let's.
a little bit.
see. Oh, you're gonna, when I show you this, you're gonna be like, oh my gosh, that was so easy. Okay, so on mine, it says we have J and K are independent. And it gives you this information. And this is what it asks for. Okay, now, can anybody explain to me, just in your own words, nothing formal, what does, if J and K are independent, what does that mean?
The outcome of one does not affect the probability of another happening.
Correct, correct. So if J and K are independent, that means if J happens first, whatever happens with K is not going to be affected by what happens with J. So a perfect example of that is rolling dice, right? If I roll a dice and I get a 2, and I want to find the probability of getting a 2 the second time, and I roll the dice a second time, whatever happened the first time does not affect the outcome of what happens the second time. So that means if I assume that K happened, right? Should that affect the probability of J?
No,
Right, so the probability of J giving K when they're independent is the same thing as saying what happens with J. These will always be the same if they're independent, because if they're independent, K doesn't matter. The outcome is going to happen no matter what. Whatever happens with K isn't going to affect J. So what would you tell me the answer for P of J would be then?
0.28.
Perfect.
Yeah, that was very simple. Yeah, I guess I just don't.
That's okay. Sometimes you just need, I mean, this is a tough subject. It takes a lot of practice. It really does. Now let me
Uh,
see, is that the same thing for,
I meant 15 and 16, not 16 and 17.
oh.
Yeah.
So you want to do 15, you said?
Yes, I did just like trial and error type deal, so I ended up getting it, but I'm sure there's a much easier way to do it.
Okay, so for my number 15, this is what it says. It says A and B are independent. And then it gives these values. And it says find the probability of B. Okay, now, the general formula for A and B, when you're trying to find the probability of A and B, the general formula is this. Or you can switch the letters around and write it like this. Either one, you'll get the same answer. Now, because they're independent, that means the outcome of one is not going to affect the other, which means the probability of B is going to be the same exact thing as the probability of B given A. These are going to be the same. So if I take this and replace it with this, because they're the same, I can do that. I can say that the probability of A and B is going to be just the probability of A times the probability of B. So if I know what A and B is, A and B is 0.33. And they give me the probability, let's see, of A is 0.6. And we're trying to find the probability of B, what would I do? So think of this as,
Multiply.
so think of this as my X, right? I'm trying to
Would you
figure out what
divide
X
the
is.
two?
I'm sorry, I couldn't hear you. What?
Would you divide the two?
Yeah, which one would you divide by which?
0.33 by 0.6.
Perfect, exactly. Because in order to solve for X, you got to divide both sides by 0.6, and then whatever you get for that is going to be your answer.
So if I divide those two, oh, just kidding, hold on. So yeah, I ended up getting 0.2222 for mine, but when I divide the two, like I'm getting 0.2424. Or is it just within the area? Like I said, I did like a trial and error. Like I kind of got close. I knew about what the numbers should be, and then just started plugging in numbers in my calculator.
What did you get? Let's use your numbers. What did you get
Okay.
for the what did they give you for the probability of A and B?
For A and B, it's 0.08.
And then what did you get? What did they give you for the probability of A?
0.36.
Okay, so you need to take and divide both sides by 0.36.
Right. Well, that gave me 0.2424, but when I put it in the thing, I ended up putting 0.2 repeating, and it still worked.
Except you're supposed to do rounded 4 decimal places. So if you're getting 0.242424 repeating, you should put in 0.2424.
Right. But what I'm trying to say is when I originally did the problem, I put in 0.2222, and that was right for whatever reason.
Huh. It might have had like a tolerance. Like a-
Okay.
Yeah, that's the only thing I can think of. It might have had a tolerance, or it could be that it switched the numbers on you. Sometimes after you do it so many times, it gives you a new version. So those are the only two things I can think of why it would do that. But do you understand it now? Is that okay?
Yes, I understand it. Thank
Okay,
you.
good. That's the most important part. Okay, now you said the other one, what was the other one you had, Brent?
17.
All right, let's look at number 17. Okay. So for number 17, it says you have 7 green cards and 5 yellow. And you randomly draw without replacement. So this is important to pay attention to the clues that they give you. So in my deck of 7 green and 5 yellow, that means I have a total of 12 cards. Okay, part A says, find the probability of G1 and G2. So G1, that little one means you pulled the green the first time, and this means the green on the second time. So if I find, what's the probability that I pull a green on the first time using my numbers?
7 out of 12.
Perfect. Now, because we don't put the card back in, because it says without replacement, now I don't have 7 green cards in there anymore. I have 6. And now my total is 11. So what's the probability of me taking a green out the second time now?
6 out of 11.
Perfect. So this is the notation for you pull a green out the first time. This is the notation I pulled a green out the second time, knowing that I pulled a green out the first time. So we're under this assumption. That's why the numbers changed. That's the 6 over 11. So I would have to just multiply those together and see what I get. So let's see. What does it say to round to? This one doesn't say. Usually I would just stick to 4 places if it doesn't tell you how to round. Usually probability is in general 4 places. So when I take 7 over 12 times 6 over 11, I'm getting 0.3182. Do you guys get that okay?
I got that.
Yeah, I got that one.
Okay. Now this next one, I'm gonna need a little bit more room, so I'm gonna raise. Okay, so for part B, now it says, we're gonna look for the probability of getting at least 1 green. So we have multiple situations where we could get at least 1 green. We could have the probability of getting 2 greens, because that is the situation where we have at least 1 green. We could get 2 greens. Or we would have the probability of getting a green on the first and a yellow on the second. Or we could get a yellow first and then a green on the second. Any one of these situations, if we pull 2 cards out, right, would be at least 1 green. Is everybody okay with that thought process?
Yeah.
Okay, so this one we already figured out in part A. This was 0.3182. So I just have to figure out these other ones and then add them together. So if I get a green on the first time, that would be 7/12. What would happen if I got a yellow the second time? What would that probability be?
5/11.
Perfect. Okay. Now for the last one, what's the probability that I get a yellow the first time?
5, 12,
And then a green the second.
and then what, 7, 11?
Perfect. So then we would just have to multiply these out and add them all together, and that would give us our answer.
Got it.
Okay, so let's see. That would be 121. Where's my calculator? I'm gonna do this with you to make sure we got it right. 12. Whoops, I must have made a mistake. What is going on with my calculator here? Gosh darn it. My phone does not, I'm using my phone calculator right now. It's not cooperating. Did anybody get it? I'm gonna rely on you guys since my phone isn't cooperating.
Yes, I got the correct answer.
Okay, what you get?
So I didn't do this one specifically. I did my question on my homework and it came out right.
Okay. Brent, did you get yours?
Give me just 1 second. I'm still doing it.
Okay, take your time. I just want to make sure that everybody gets it.
I believe your answer is 0.5303.
I'm gonna pull up my calculator on my computer. Divided by 12 times divided by 11. I'm getting 0.8485.
I'm not exactly sure. Oh, I didn't add in the 0.3182. Okay, yeah, I got the
Got it?
0.8485. Yeah, I just
Okay.
forgot that first number.
Awesome. Okay, did everybody get part B okay that needs that question on theirs?
I got it.
Okay. All right, now the last part of that, we want to find the probability of getting a green on the second, making the assumption that we got a green the first time. If I got a green the first time when I picked, that means I have 6 greens left out of 11. So when I go to pick a green, the probability of getting a green the second time would be 6 out of 11 because I only have 6 out of 11 left. So this tells me to make an assumption that we already picked green. So we want to see what happens when we pick green the second time. Now, if it said, make the assumption that we picked a yellow. So if we had this, let me do another part, we'll make up a part D. What's the probability of getting a green the second time if I pick yellow the first time? So I could assume that I already picked a yellow, which means I would have 4 yellow. I would still have 7 green, but I would have a total of 11. So that would be a 7 out of 11 if we made the assumption that we picked a yellow. Do you guys see how that works?
Yes.
So whatever that second part is that says given, you need to make that assumption when you're making the probability of whatever it is that they're asking you for. Okay. What else do you guys want to go over?
Question 13.
Okay, question 13. Is this the one with the marbles?
Yes, please.
Okay, so number 13 says we have a bag of marbles. There's 3 blue, 3 white, and 6 red. And it says they are not returned. So this is without replacement. All right, so part A says, what's the probability of getting a blue and then a red? I'm going to label it like this. A blue the first time and then a red the second time. Okay, so if I get a blue the first time, let's see, there's 6 and 6, so there's a total of 12 marbles based on my numbers. Okay, so if I get a blue the first time, that would give me a 3 out of 12 chance. So this is the notation of probability of blue. Now I got to do the probability of picking a red the second time, knowing that we've already picked a blue. So if I picked a blue, that means now I only have 2 left for the blue and 11 in total. So what's the probability of picking a red the second time?
Um, 6/11.
Yeah, exactly. So that's what I would have to multiply. So this is my conditional. Because it's without replacement, the second time is going to be affected by the first time. Okay, so then whatever you get for that, I'll let you figure that out. It says, does it say? It says put it in as a reduced fraction. So if we reduce that, this would be a 2, this would be a 1. So it'd be 3/22 for me. Aside, do you have the same numbers that I do, or is yours different?
Mine is different, but that's
Are you
fine.
able to follow along okay?
Yes, I am.
Okay, good. Are you ready to go to part B yet? Or are you still working on part A?
Oh, I'm ready. I'm
Okay,
ready.
I didn't want to jump ahead too fast. Okay, so part B says, find the probability of getting a red the first time and then a white the second time. So we need to find the probability of getting a red and then a probability of getting a white the second time, given that we already had a red. So if I got a red the first time, that's 6 out of 12 for me. Which means if I picked a red, I'm down 1 red. and now my total went down to 11. So now my chances of getting a white given that I already picked a red, is going to be 3 out of 11. And then to reduce that, that would be a 4, and then this would be a 3, this would be a 2. So for me, it would be 3 out of 22. Oh, Sal, you good?
Yes, I am.
Okay, so the next part is we get a blue all 3 times, a blue on the first try, then a blue on the second try, and then a blue on the third try. So we just gonna have to take into consideration each time what we have left in our bag. So we start with 3 blues. So I get a 3 out of 12 chance. So if I pick a blue the first time and I go to figure out what I get, what's the chance of getting a blue the second time, that would be 2 out of 11. And then what would be for the third time?
1/10.
Right, perfect. Yep. And then you just have to multiply that together and put your answer in.
Okay. Thank you.
Did you get it okay?
Yes, I did. Thank you.
Perfect, perfect. Okay. So that was number 13. Anything else?
21.
21. You sounded like you've been waiting for a long time to yell that out. Okay, let me clear all this out. All right, 21. Okay, this one, is this the one about the drug rehab center?
Yeah.
Yes.
Okay, just wanted to make sure. Okay, so we have a drug rehab center and it says, for my numbers, it says 36% experience depression. So I'm going to use D for depression. So the probability of depression would be 36%, which is 0.36. Okay, then it says the probability of weight gain. I'll do W for weight gain. That gives me, that's 0.29. And then it says 13% experience both. So then I'm going to write the probability of D and W is 0.13. Is everybody okay with that notation?
I'm good.
All right, just stop me if you have a question. Okay, part A says, find the probability that they don't experience depression or weight gain. So you kind of have to think backwards on this one. If we have 100% of people and we subtract off the people that experience depression, that's 36%. And then we subtract off the people that have weight gain, that's 29%. But then there's 13% that experience both, and I don't want to count them twice. So I'm going to add that 13% back in because I don't want to subtract that off twice. So Hopefully my phone calculator is gonna cooperate. Otherwise, I'll have to pull up my calculator again. Let's see. So 100% minus 36 minus 29, and then I want to add the 13% back on because I don't want to subtract that off twice. So I'm getting, if my calculator is cooperating, I'm getting 48% or 0.48. Let me double check. Make sure I did that right. Minus 29, and then add the 13 back on that we don't want to count twice. Yeah, I'm getting 48.
I got that.
You got it, okay?
I wasn't the one who asked the question though.
Yeah, who was it that asked? Was that you, Wesley?
Yeah, my problem wasn't the same, but I just kind of used your formula there and I got the right answer for my question.
Perfect. Do you understand why I'm subtracting, or do you understand why I'm adding the 13 back in?
Yeah.
Okay. All right, let's do part B then. Let's see, what is the probability that someone experiences depression given that they experience weight gain? So we basically have to take it out of the weight gain population. Now they don't give us specific numbers as far as how many, so we can just use the formula, the probability of D and W is equal to the probability of getting weight gain times the probability of depression given that you have weight gain. So we're going to use this formula. And so I'm just going to plug in the values that we have and then solve for the unknown. So I know my D and W probability is 0.13. So I'm going to put that under here. My probability of W is 0.29, and this is what I'm looking for, so I'm going to call that X. So how do I solve that for X? Anybody want to take a stab at that? How do I figure out what X is?
No clue.
You're gonna subtract 0.29 from 0.13.
Not subtract. Okay, let me ask you this. If I said 12 is equal to 3 times what? What would that question mark be?
4 or
4, right? Because we know that fact, right? But if I wanted to think about how I would actually get that, I would take 12 divided by 3. I work backwards. So I'm going to take 0.13, right, and divide both sides by 0.29. That way I can cross those off and then whatever I get for that. So 0.13 divided by 0.29. I'm getting 0.4483. The best thing to do, I think, at least it helps me, is when you're trying to figure out something that seems like it should be simple, but for some reason your brain just isn't working. Compare it to something that you're comfortable with, like the 3 times 4. We know that. Okay, how do I solve for that? Okay, kind of go back and compare it to something that you're familiar with. Wesley, does that help you with part B?
Yeah, I just got the right answer for my problem.
Okay, perfect. Okay, so let's go on to part C then. Okay, part C says, find the probability that you experience, oh, so they're just asking it in reversed. They're asking for this now. So we're doing the same thing that we just did before. We're just switching the letters. So,
I'm sorry, I just like submitted mine with that and it was still wrong.
do you have
For
different
B.
numbers?
I used different numbers.
Okay, let's back up then. Hold
Sorry.
on. No, that's okay. I don't want to jump ahead, so don't worry. Okay, what are your numbers? What's your probability for D?
41%,
Okay, what's your probability for W?
30%,
And then what's your probability for D and W?
15%.
Okay, so then for you, does yours ask for the probability of depression given weight gain?
Yes.
Okay, so then you're gonna take your 0.15 and you are going to divide by, that was that. So you're gonna divide by 0.3. You should get 0.5. When you take 0.15 and divide by 0.3, did you get 0.5?
Oh, okay, I got it. I must have entered it wrong on my calculator.
Okay. All right.
Oh, I used 0.13. I accidentally looked at the screen.
Oh, I do that all
That
the
would make
time.
sense. Yeah.
I do that all the time.
Okay, thank
Okay.
you.
So part C is we're just reversing it. We're saying find the probability of weight gain given depression. So we're going to do the same thing, but we're just going to switch the letters around. So we're going to find the probability of D and W, but we're going to use the other equation where we switch. So we're going to do the probability of D times the probability of W given D. So we have, for me, it's 0.13 for D and W, and then probability of D is 0.36. So for me, I'm going to divide both sides by 0.36. Let me see what I get. 0.13 divided by 0.36. I'm getting 0.3611. Hey, guys. Hey, I'm in class right now, so just don't interrupt unless it's an emergency, okay?
All right.
Thank you. Sorry, my kids just got home from school.
Wait, so we're supposed to divide by the probability of depression, right?
Correct. So whatever you have for your and probability, divide that number by whatever you get for your probability of depression.
Okay.
And then it says round to 4 places. Thank you, honey. Do your chores first before you do that, okay? Just today. Yes,
Okay, that was right.
you got it.
Mm-hmm.
Perfect. Okay, then there's a part D and E. Do you guys need help with that too, or was it just the probability stuff?
Mine was just the probability stuff.
Okay. All right. Do you guys feel like this is helping? Are you starting to feel a little bit better? Or are you guys?
Yes, I've been able to answer 1 or 2 other questions by myself because of the formulas that we've gone over.
Good, 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 good. I'm glad. This is a tough subject, especially if you're doing this for the first time. It really does take a lot of practice. So when students start doing this for the first time and they get nervous and they're like, I can't do this, I can't do this. You can do it. I'm telling you, you can. It just takes practice. It's not something that comes right away. Okay, so that was number 21. What else do you guys want to do?
How about number 20?
Okay. Okay, let's see. It says in number 20, 55% of all statistics classes require a calculator. Okay, so I'm gonna label C as calculator. So calculator is 0.55. Okay, let's see. It says 29% require the use of a computer. Oh. I'll do CM for computer. I'll do CA for calculator. That way it doesn't get confusing. And then for me, that would be 29%, so 0.29. And then let's see, of classes that require a calculator, 15% also require the use of a computer. So this would be, we're taking this probability out of the students that are required already to have a calculator. So it's going to look like this. That's going to be, for me, 15%. So we're looking at it of the students that are required to have a calculator. So we're taking it out of not the whole group. We're breaking it down to that specific group of just those with the calculator. Does everybody see how that's worded? That this is a conditional?
Yes, I see it.
Okay. Does anybody need me to go back over that, or is everybody okay with it?
I'm fine.
Okay. So part A says, what's the probability of requiring a calculator? That was given, so that's 0.55 for me.
Yeah, the parts I had trouble with were C and D. I don't know about anyone else.
Yeah, because the
I
first
had trouble
two-
with D.
Yeah, the first two is information that was given to you. I think they're just wanting you to read the problem. So that was, the second part was the computer one. So that was 0.29. Okay, so part C says, find the probability that you're required to have a calculator given that you are required to have the software. So that's the computer. Okay, so this is what we're trying to find. So I'm going to use, let me think what would be the best. Oh, wait a minute. Oh, I read that wrong. My bad. Sorry, I read that wrong. Mine is the probability of a calculator and software. So that's this. Okay, now there's two possible formulas for this. Remember, because you can switch the order. So this is the probability of CA times CM given CA, or we could use this formula, CM times the probability of CA given CM. Which one do we have the information for? If I call this equation 1 and equation 2, which one do we have the information for?
CA and CM, or CM given CA.
Yeah, so that's this first one. This is what we have the information for. So I'm going to use that first one. So I'm going to take the probability of CA, which is 0.55, times the 0.15. And that gives me, let's see, 0.55 times 0.15. I'm getting 0.0825. Did everybody get C okay? Can I go on to D? Or do you need me to wait another minute?
I got it.
Anybody need more time? Okay. All right, part D says, let's see. Find the probability that you're required to have a calculator given that you have the software. So now I'm just gonna do the same thing I just did, but now I'm gonna use this equation because we're looking for this. And I have this information and I have this information from part C. Let me make more room here because I'm running out at the bottom here. So I'm gonna write it out nice and clear up here. So for part D, we're gonna use the probability of CA and CM is equal to the probability of CM times the probability of CA given CM. So in my problem, I got that the and probability was 0.0825. And I was given that the probability of requiring software with the computer was 0.29. And this is what I'm looking for. So I'll label that X and then I'll just divide both sides by 0.29. So 0.0825 divided by 0.29. So I'm getting for me 0.2844 for part D. Did anybody not get their answer that they need? Oh, I think I just see a text chat thing. Let's see. Okay, Kaylee. Okay, so everybody got D okay for that? All right. What else do you guys want to go over?
Oh, I just have two left, question 19 and question 25.
Okay, 19 and 25.
Yeah, and on 19, it's just part D.
Okay. 19. Okay, for number 19, that's the one with the cats and the dogs. Does anybody need me to go through the previous parts of that? Okay, so for number 19, mine says that the probability of owning a dog is 0.53. The probability of owning a cat is 0.69. And then of the dog owner, so we're taking it out of the dog owner, so this is conditional. 44% also owns a cat. So the probability of having a cat, given that you already have a dog, is 0.44. Does that help, Morgan?
Sorry, 1 second. I'm trying to write this down.
Okay.
Mine says own a dog given a cat.
Oh, I'm just writing down the information that was given to me in the problem. I'm not quite ready to answer the question yet. I'm just writing stuff down.
Oh, okay. I'm sorry.
No, that's okay. So for you, so that second sentence in the problem says of the dog owners, right? So that means we're
Mhm.
taking it out of the dog owners. That's why I put this notation here. The probability of having a cat is 0.44, given that you already own a dog. That's where that notation is coming from.
Okay, so if mine says of the dog owners, 46% own a cat, would mine be 0.46?
Yep, so you're gonna write it just like this, but 0.46 for you.
Okay.
And then for part D, to answer the question, this says, what's the probability of owning a dog given that you own a cat? So we're just doing kind of the reverse of this one that was
Okay.
given. Okay, so let me think. Own. You know what? We have to do we have to do part C in order to get part D. So let me back up a little for a second. Because I don't have that answer yet because I haven't done it yet. So part C says, find the probability of having a cat and a dog. So I'm going to use the formula, find the probability of a dog times the probability of cat given a dog. So that would be 0.53 times 0.44 for me. So 0.53 times 0.44. So for me, that's going to be 0.2332. And you said you were able to get part C, correct? Because you need that to answer part D.
Yes, I did.
Okay. All right. So now that I have my answer to part C, let me erase and make more room. Okay, so for part D, we need to find the probability of owning a dog, given that we have a cat. So we're going to use this formula. We're looking for this, but we have these two pieces, right? This was my answer to part C, and this one was given to us, the probability of having a cat.
Okay.
So for me, my answer was 0.2332 for the and statement. And then 0.69 for the probability of having a cat. And then I solve it for X.
And then do I divide by the probability of owning a cat?
Yeah,
both
so
of
you're
them?
gonna take, so looking at my numbers, I would take 0.2332 and divide by 0.69. You're just gonna divide both sides of the equation by whatever your probability of a cat is.
Okay. Okay, that was right.
Okay, perfect. And then you said you also had number 25?
Yeah, it was part C, D, and E.
Actually, before I erased it, I should have asked. Did everybody else get that okay before it's too late now, but is everybody okay with that cat and dog problem?
I am.
Okay. All right, number, whoops, you said number 25. All right, number 25 gives you a whole bunch of information about peanut M&Ms. And now I'm starting to crave M&Ms because I'm a chocoholic. Let's see. It says, so we have, my numbers are 12% are brown. 15% are yellow. And then it says 12% is red. Man, my eyes are really bad. 23 are blue. 23 is orange. And 15% are green. Morgan, do you have those same numbers or are yours different?
I actually do have those same numbers.
Oh, perfect. Okay, before we go on, I'm just gonna quickly check because I'm paranoid. I just want to make sure that these all add up to 100 to make sure we didn't miss anything. Plus 23, plus 23, plus 15. Yeah, okay, so part A. Compute the probability that a randomly selected peanut is not brown. So did you want me to go through all of these or was it just certain ones?
Well, I got A and B correct.
Okay, so does anybody need me to do A and B?
You can just go ahead and do A and B.
Okay, so part
you.
A is not brown. So basically you're gonna add up all the percentages that are not brown. So that's gonna give you 88%. Right, if I take 15, 12, 23, 23, and 15, that should be 88%. Does it say to put it as a percent? Let's see. No, it says put it as a decimal. So you should put in 0.88. Osai, was that the same? Do you have the same numbers too, or the same questions?
Yes, I have the same.
Oh, good, good. So that there's not going to be confusion. Okay. Part B says, compute the probability that a randomly selected peanut is blue or green. So we just add the blues and the greens. So blue is 23, green is 15. So that would be 38%. So you put it in as 0.38. You get it okay, Osai?
Can you explain the B part again? Sorry, I didn't quite get that.
Okay, so part B says you want to find the probability that you get a blue or a green M&M. So I just took the blue and the green and I added them up.
Okay. All right, thank you.
You're welcome. Okay, part C, compute the probability that 3 randomly selected peanuts are all, or M&Ms are all red. Does it say if they're replaced or not?
It doesn't on my screen.
Yeah, mine doesn't say either. So we could just do it both ways and I'll check to see what the answer is. And then I'll have to make a note to, oh, you know what? I think I did make a note to change this and I haven't gotten to it yet. It should
I
say in there
think
whether,
would it mean that they weren't replaced if you're drawing them at like the same time, or?
if you're picking one out and then you put it back. So if it's the same probability each time, then that means you're putting it back. But if it were me, I would eat it. It wouldn't go back in that bag. But it should stay in there. Let's see. Let me calculate it both ways and I'll tell you, because it should stay in there. If it is replaced, what's the red? The red is 0.12. So if I pick 3, that means I take 0.12 minus 0.12 times 0.12, which would be 0.12 times 0.12 times 0.12. I would get, because this would be the first pick, the second pick, and the third pick, right? You multiply by the probability. This would be with replacement. I'm assuming that it would have to be with replacement because they didn't tell you how many M&Ms to figure out. Like if you ate it and you didn't put it back in, then you'd have to subtract 1 off the total, right? So I'm assuming it's gotta be with replacement because they didn't give you enough information really to figure it out otherwise. But they should say in there, I'm getting 0.001728. And it says to round to 4 places. So try putting in 0.0017 and see if that works.
My C is the probability of 2 randomly selected yellow ones. So I'm using the same formula, but I'm gonna see if it's right.
Oh, for yellow, then do 0.15 times 0.15. Because you're doing it twice, so multiply it twice.
Oh, wait, you didn't, so wait, that's not like 0.12 over 2. You're just like labeling them.
Yeah, this is, I'm sorry, that's first pick, second pick, third pick.
Oh, okay, I thought we were dividing by 1, 2, and 3. That was
No, no, I'm sorry. It's for me because mine says pick 3 regs. So I looked at my
Okay.
red percentage and did 0.12 times 0.12 times 0.12.
Okay, that makes sense. So I do 0.15 times 0.15.
Right, because yours said yellow twice, right?
Yes.
Yeah, so then do that.
Okay. Okay, that one was right.
It worked, okay. Osai, were you able to get it okay?
Yes, it was the same thing.
Okay,
Two
so
yellows.
this is with replacement, and they didn't state that in the problem. So I have to go back in and see if I have access, whoever edited that. I'm gonna go see if I have access to change that, or I have to email the owner. Okay, and then was it just C? Did you say you had another one, Morgan?
Oh yeah, it was also D and E.
Okay, so let's go back and look at D and E also. Okay, D said if you randomly select 3 peanut M&Ms, compute the probability that none of them are red. What is yours the same thing?
It's selecting 3, but none of them are yellow.
Okay, so this would be the first pick, second pick, third pick. So you just multiply that together. If none of them are yellow, then you just add up all the percentages that aren't yellow. So that would be 0.85. Right? Because if you take out the yellows, if you do 100 minus that 15%, that's 0.85 if you add up all the other ones. You follow what I'm saying, Morgan?
Yeah.
And then if you do that 3 times, it should be 0.85. I'm getting 0.6141.
Yep, that's what I got. Okay, yeah, that worked.
Okay, then the last part, part E, do you have it that at least one of them is red?
Yeah, it says if you randomly select 3, what's the probability at least one of them's yellow?
Oh yeah, for you it's yellow. Okay, so then what you want to do with the at least, the formula for at least, when you have independent events, and this is independent because they're doing with replacement. So independent, you can use this formula, 1 minus the complement of the event raised to the n. So in your case, the event is that you what did you say? You didn't pick a yellow, correct?
It says probability that at least one is yellow.
Oh, okay, so we're gonna say yellow. So your event is that it's yellow. So a complement is that it is not yellow.
Okay.
And then n is the number of trials. And you said you're doing it 3 times?
Yes.
Okay, so your n would be 3. So you would do 1 minus, if it's not yellow, that means it's 0.85. And then you would raise it to the 3rd power. So whatever you got, basically whatever you got from the part D, you just subtract it from 1. Because that's what I think we did in part D, wasn't it? Where we just took 0.85 3 times.
I think so. Okay, I'll subtract this.
So if you subtract that from 1, that should work for part E.
Got 0.3859. Oh, yep, that was right.
Okay, so whenever you have independent events and the question says at least once, you can use this formula, but it only works if it's independent.
Okay.
Aside, did you get it with your question? Okay.
Yes,
Okay.
yes, I did. It was the same question.
Okay, awesome. All right, where did my pencil go? Oh, here it is. I think it might be really helpful for you guys if I go real quick over, if you have time, if we go over real quick, the formulas, just a general summary, because I think if you have like a little cheat sheet to go back and look at, it might help. I don't
Okay.
know, you want to do that?
Yeah,
fine
that'd
with
be
me.
awesome.
Okay, so probability formulas. All right, so the first one is if you have an or statement. You want to add the two probabilities together, and if there's overlap, you subtract that overlap. In the special case that it's mutually exclusive, so that's why I put the little ME here. That's me being lazy. I don't want to write out mutually exclusive. In the case that it's mutually exclusive where there's no overlap, then you just have to add those two probabilities together, because this would be 0, right? If there's no overlap. And just a quick
Okay.
note, mutually exclusive means they can't happen at the same time. So that's the or stuff. You guys okay with that?
Yeah, that makes sense.
Okay, now for the and stuff. There's two possible equations, because remember you can switch. You could have the probability of A times the probability B given that A has happened. Or you can switch it where you do the probability of B times the probability of A that B has happened. So this is if they are dependent, where these are going to change based on whether A or B happened. Now, if they're independent, then you literally just take the probability of A times the probability of B, because then, let me put a little clause down here, because the probability of A is going to be equal to the probability of A given B, because it doesn't matter if B happened or not, it's still going to be the same. Same thing with this. This is if it's independent, then you have that happen. So this is your special case for the and when it's independent.
Cheeseburger and fries. I'm doing a math class.
Okay, and then the last formula that you should know, well, you don't have to memorize these because you'll have access to your books when you're doing the quizzes and the tests, but you should understand them. But if the events are independent, then you can use this formula for the at least one situation. The probability of at least one, right? If you're talking about event A, is just 1 minus the probability of the complement of that, whatever the opposite is, raised to the power of n, where n is the number of trials. So you,
So I can't see the bottom of your screen. Oh,
okay, can you see it now?
When it like, yeah, right now I can.
Okay. Let me hold it up for a second. So
Okay.
you can use that at least formula, but you have to make sure you put that it only works when it's independent. So you would subtract the probability of the complement happening when you raise it to the nth power. So an n would be
Okay.
like the number of trials. Like, so if you're talking about dice, it would be the number of times that you roll the dice, or the number of picks, or whatever.
Okay.
There's really only those 3 formulas, the and, the or, and the at least. It just, I think it gets confusing because of the special cases where you have to keep in mind whether it could be mutually exclusive or independent.
Yeah, I think that was the biggest thing that threw me off is when they gave us problems in like percentages and they were like special cases for it.
Yeah.
Mixed up.
But I promise you, keep practicing and you'll get it. It's just hard until you get comfortable with it. But if you keep this cheat sheet that I just went over with you with this formulas on it, in front of you while you're working, I think it's going to help start clear things up for you when you step back and look at the big picture.
Mhm.
All right. Is everybody's brains fried? I'm about done.
Yeah.
You guys done?
Yeah.
Thank you for taking the time to explain. It really helped a lot.
Good. I'm so glad. That is the I knew that the probability was going to be an issue because it always is. So I always try to anticipate when you guys are going to get to like a sticking point. So I make sure I have these study sessions. So if you ever feel like you need another study session, let me know and we'll plan it. Okay.
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 All right. You guys have a good night.
All right.
You
You too.
too.
Thank
You
you.
as well.
Thank you.
See ya.